Welcome to General Structures 2, Lesson 3, Example number 1. And first of all, I think I messed up here in the last video, so I apologize, but we'll make a quick fix. And what I think I forgot to do is I forgot to put that external reaction in. And that's one of those things that you can forget to do. So you have to make sure when you go to the joints that you get all your reactions internal and external. And sometimes it's easy to remember the reaction, but I wouldn't call them reaction, external loads, let's call them. And I think I forgot to put this 3 kip load on there, so let's go ahead and do it again. Alright, B, here it is. I'll try to go a little bit faster. I'll put the B out to the side. We have this 3 kip load, which I believe that I forgot last time. Then we have a 4.95 kip load. Whoa, what was that? And then we also had this. Let's draw that over again. So don't make that mistake that I do and just check your numbers. This is 45 degrees. This is 90. Alright, so we had what? FBD, which is up here. And then we have FBC. And I'm not forgetting anything, am I? No, we have our external load. We have our internal load that we know. And we have our 2 unknowns. And we're good. So let's go ahead and move on. Alright, we know that this is in compression. See, I messed up. And remember, when you see compression, that means it's going in to the joint. So we could even draw this one like that. And if you feel more comfortable doing that, then drawing a compression load goes in, tension goes out. It's positive, compression will be negative. Alright, we're all good in the world. No more mistakes. Now we want to do the same thing. We want to isolate one of these loads if we can. If we remember back to the last video, these are going to be 3.5 kips and 3.5 kips for the components. And then we're also going to have our FBC components, and then the FBD doesn't need to bring out into components because it's simply an X direction, so we don't need to worry about it. And this is going to be FBCX, and this one up here will be FBCY. And we have to figure out which one can be isolated. We see we have 2 horizontal reactions, and therefore we need to do the sum of the forces about the vertical, or the y-axis, and that we only have 1 unknown vertical load, so we're going to go ahead and do that. Let's start and go from left to right. We see we have a positive 3.5 kips. We have a negative 3 kips load coming in, and then we have this, since it's going down, it's a negative FBCY. Alright, and we'll see we get a positive, right here we get a positive 0.5 kips divided by FBCY, BCY, so that'll equal 0.5. I said divided by, I didn't mean that. You'll have to multiply by a negative point FBCY, or divide by an FBCY. I think I made that clear. Anyways, you subtract by it, and it'll go over here. It will become positive. No, you need to add a FBCY. I'm losing it. It's late. Anyways, add a FBCY. That'll cross these 2 out. Negative FBCY plus FBCY equals 0. You'll get a positive over here, so positive FBCY equals 0.5 kips. Alright, now we also know that since that's a 45, 45, 90 triangle, that FBCX equals 0.5. And you can go through your trig stuff, or you can just you can do Pythagorean theorem. I am really losing it tonight. I must be tired. Pythagorean theorem to get this as well. Alright, so no, not to get that. Use your trig identities. To get this, you will use your Pythagorean theorem, which is going to be 0.5 squared plus 0.5 squared. And then you want to do divided by 5. No, to the 0.5, sorry. the square root of that, in other words. And you get 0.707, and that's kips. Alright, so we know that. Let's go ahead and put that on there. And remember, that's FBC. Let's put 0.707 kips. You could do 0.71 since I used two sig figs right there. Really doesn't matter. Alright, and whoa, I need to put that in tension or compression. And it is going to be, since it's positive, it will be in tension. So we want to put that on there. T for tension. Alright, now let's go ahead and erase this work. And we're going to sum the forces in the x direction, because now we only have one unknown. And we're going to solve for that. Okay, we have a positive 3.5 kips. We come over here, we have another positive 0.5 kips. Remember, FBCX is 0.5 plus 0.5 kips. And then we have another positive FBD. And if you come out, you will get FBD equals a negative 4.0 kips, and that's going to be in compression. And hopefully that makes sense. If you just think of a beam, and if this was just a beam looking like this, and that was the top flange up here, this was the bottom flange, and this was the web. If you think about it, if I have a load right there and a load right there, what's going to happen? It's going to be in positive moment. It's going to look like a smiley face. The bottom flange will be in tension. The top flange will be in compression. Sure, that makes sense. Essentially the top chord or top flange is in compression. So it's 4.0 kips, and that is in compression. All right. And that is those. Now we want to move on. And you can box that up. If you're doing calcs, that's what I'd do. I'd box up all my members. So I'd say we had FBD equals 4.0 kips compression, and I'd put a box around that like this, the answer, so you can easily find it, and then also on your diagram you can put it up there. So let's move on. I'm going to change colors again, and we can go to joint C. Remember, we're doing the method of joints. I'm going to try to hurry up. I think you've got the point of what we're doing. This is a right angle. These are 45. 45, and we've got tension right here, so that's coming out, and that's 0.707 kips. And if you'll remember that the components were 0.5 kips each, and then over here we have what? 3.5 kips tension. Let's go ahead and keep with the color scheme here. 3.5 kips, and we know its tension is coming out, so we make it tension, and that doesn't need any components because it's a horizontal load already. An X direction, and now we're going to assume that FCD is positive in tension. We're going to assume FCE is in tension. Now, if you think about it, this is going to turn out the same way that we've been doing the rest of these, because let me change colors actually so you don't confuse it with that green over there. Or we're going to have to go to the Y direction again. Sum the forces in the Y direction, and that will isolate this one FCDY. And this right here is this is FCDY. CDX. Alright, so let's go ahead and just do that. Because we couldn't, if we tried to do in the X direction, we have two unknowns, it's not going to work out. We only want one unknown, because then we can solve for that unknown right now. And eventually you'll be able, if it comes to it, sometimes you're going to have to do simultaneous equations, do two different equations. You're going to have to substitute in one of the unknowns to one of your other equations, and you can make it work out that way, but this is the easiest way. Do it the easiest way. Okay, so the sum of forces in the Y direction, we have 0.5 going up, We also have FCDY. We assume it's going up. And I don't believe we have any more. So FCDY is going to equal a negative 0.5, which that's going to be in compression, which you can leave that negative there if you wish. And because we know that since they are a right triangle, that's 45 45, this whoa, I got out of control. FCDX is going to be equal to 0.5 kips in compression, or negative 0.5 kips in compression. So when we use the Pythagorean theorem, we also get 0.707. So FCD is going to equal 0.707 kips, and that is also going to be in compression. And you can box that up on your calc paper. There you go. We also can put it up here on our diagram. 0.707 kips in compression. Alright, now we only have one more member on this, and then we can hopefully get this done real quick. Okay, our last member, we're going to sum the forces in the x direction, and we have a negative 3.5. Since this is going to the left, we're going to have a negative 0.5 kips. Going to the left, we're going to have a positive. No, it's going to be negative. Because remember we said it was in compression, so we actually changed arrows there. A negative 0.707 kips. They're going to have a positive FCE. And FCE is going to equal the sum of all of those, which is going to be 3.5 plus 0.5 plus 0.707. Scratch that, that's not 0.707. That's another 0.5. And this is easier when you have calc paper, because I would be able to go up there and see what FCDX is, as opposed to just trying to remember it off the top of my head. So FCDX is also 0.5 kips. So we have a total of what? 4.5 FCE, and that's going to be negative, so therefore we're going to put it on the other side. It's going to turn positive. So FCE is going to be positive, and it's going to be a positive 4.5 kips, and that's going to be in tension. Alright, so this is, you can put it down here I guess, but we'll leave it up the top. 4.5 in tension. Alright, now we're on to our last joint. And we could do either up top or down low. I choose to do the least of the two because it has less, it has less less members, so it's easier in my mind. It may not, whatever you feel. This is going to be 4.5 kips. We're going to have our unknown, which we're going to assume it's positive, which you can do that if you like showing a member. You can also show you need to show the 4.5 kips in tension right here. Alright, and since, well, we could solve for either. Obviously 4.5, 4.5, well, we know that the components have to equal 4.5. It's going to have to be in compression, and it's going to have to be looking like that. I hope that makes sense. This is going to have to equal 4.5 kips. This is going to have to equal 4.5 kips, and therefore we know that FDE is going to equal to, I'll write it out, FDE is going to have to equal, for the first time I've written out this Pythagorean theorem, 4.5 kips plus squared 4.5 kips squared. There you go, which I'll do it in my calculator. 4.5 squared plus 4.5 squared equals to the 0.5 is 6.36. I hope I did that correctly. So FDE equals 6.36 kips. And I have 10 seconds left, so I'll go ahead and put this on 6.36 kips. And we have found all the internal forces for each member. I'll see you in the next video.